Here we have to figure out if butanol or propanoic acid have the lower boiling point and explain why their vapor pressures differ. This is the structure of butanol, which is an aldehyde. And this is the structure of propanoic acid, a carboxylic acid. The boiling point and the vapor pressure of a compound depend on the strength of its intermolecular forces of attraction. But the strength of intermolecular forces has an opposite effect on boiling point and vapor pressure. So let's draw in two molecules of each substance and investigate the intermolecular forces. The oxygen atom in butanol has a delta minus charge since it is highly electronegative, and the carbon atom to which it is bonded has a delta positive charge. The delta positive carbon on one molecule is attracted to the delta negative oxygen on an adjacent molecule. This force of attraction that is formed is a dipole-dipole attraction. Now there are also very weak London forces between these molecules, which arise from temporary dipoles, but the strongest intermolecular force in butanol is a dipole-dipole force. In propanoic acid, there are also dipole-dipole forces and London forces. However, these are not the strongest intermolecular forces. In propanoic acid, the hydroxyl oxygen has a slight negative charge, and the hydroxyl hydrogen a slight positive charge. These delta minus and delta plus charges are more pronounced or stronger than the charges on the carbonyl. A delta negative oxygen on one propanoic acid molecule is attracted to the delta positive hydrogen on an adjacent molecule. This force of attraction is a hydrogen bond, since the highly electronegative atom is bonded to a hydrogen specifically. Now dipole-dipole forces are weaker and hydrogen bonds are stronger. Little energy is required to overcome the weaker dipole-dipole forces during boiling, and so butanol has a lower boiling point. More energy is required to overcome the stronger hydrogen bond forces during boiling, and so propanoic acid molecules have a higher boiling point. For the first part of the question, we can conclude that butanol has the lower boiling point. Then we can see that the vapor pressure of propanoic acid is much lower than that of butanol, and we need to explain this. We have already seen that the strongest intermolecular forces in the aldehyde are dipole-dipole forces, which are relatively weak, while propanoic acid has strong hydrogen bonds. We also said more energy is required to overcome the forces between propanoic acid molecules. As a result, propanoic acid evaporates less readily and has a lower vapor pressure than butanol, which evaporates more readily. You would need to write a similar explanation in a short paragraph for the marks.